what would you say are the sort of 2 or 3 major achievements in the field when we sort of look at the applications of computational linguistics? Would it be possible to say that or highlight a few things that really stand out in the field? I know it is a very difficult question because people have probably different perspectives on that, but from your perspective.
So perhaps kind of it's always a personal perspective because it's such a huge field. And but what was very interesting to me was in my dissertation research when I worked on non-final construction syndrome, kind of theoretical linguistic topic in a formal framework, HBSG, and we implemented grammar. So we were actually interested in figuring out what are the consequences of our theories. Do all these things that we postulate actually work together and predict certain things for new data? And you have test suites, and it was in a sense empirically validated, but it didn't ask the question what's actually out there in terms of language. And then so the first kind of, for coupling, I think computation, I always say coupling, so in computational linguistics, the first kind of major step for me was seeing that you can actually test the consequences of your theories. And that for me was a real highlight, because theories become very complicated, and without a way to kind of, using a machine, first formalize it to a level where it can even be tested, and then also have the machine help you look at the consequences. What does it license? What does it not license? Where does compositionality help you? Where does it not? So compositionality, the idea is that you try to figure out what the sentence means, and of course it has to do with what the words mean and the way they're combined. But lots of times, when you have things like kick the bucket or something like this, it can mean 2 different things. Either there is a real bucket, or it basically means metaphorical thing. And so you want to figure out when is it the case that it's more or less derived from the parts, and when is it not derived, and when do you have to store more of things, when is it not compositional. And so in those days the focus was on the compositional part. And then the next thing in computational linguistics for me was that when you ask a linguist about parts of speech, and they say, oh, it's actually quite complicated. There's distributional and there's morphology. So distributional.
You'll never get a straightforward answer from a linguist.
Exactly. It's like lots of. You always zoom in on adverbs. Oh, adverbs is this kind of bucket category that there's all kind of stuff in there, and it isn't almost anything you couldn't properly characterize. Well, it must be an adverb, or it must be. And so you ask yourself on particles, and then you say, well, particles and prepositions, shouldn't we keep them together because we can't nicely, like the B and C tag said, actually, that was in the Penn tree bank. There was a discussion about should we separate particles from prepositions. They said, well, oftentimes we'll get it wrong. Let's not do it. And then there was another nice thing in the clause 7, clause 5, when the B and C tag enhancement project said sometimes it's better to have more classes. And that was, so you can, in each of these issues, you can spend a lifetime. And then, but in computational linguistics, what was quite astonishing was that despite the fact that we can spend a lifetime arguing about some issues, we can actually part a speech tag, the Wall Street Journal, or some possibly more interesting data domain, with high accuracy, say 97% accuracy or something like this, which still means a lot of times you'll get things wrong. For specific things, you might get them wrong all the time, which are rare.
But overall, this is a very good
and that is amazing. If you think about it, that just by looking at limited evidence with a machine, trigram tagger, so meaning a sequence of 3 words, and since it moves, of course, it can look a bit further, but in principle, the idea is, let's not look at the worst case, let's look at the common case. And that, to me, that was quite an amazing achievement in computational linguistics, to show that despite the fact that you don't know everything, and often in many contexts you can actually do a pretty good job for a lot of data.
So would you say the sort of major achievements for you would be in the area of methodologies and techniques, computational techniques that enable us to handle large amounts of data, like the sort of billions of words in sort of current language corpora, which no one can annotate manually. But if you have a part of speech tagger, like the clause, for instance, that can sort of do the job in very quickly and very reliably, 97% reliability.
And that allows you, exactly, that is, I think, but you need both. So the amazing thing is, while in the old days, kind of older days, so 90s, the focus was so much on the theory-driven work and kind of making sure you get the consequence of your theory, then the issue was how much, what does 97% mean? It still means 3% wrong. So for example, the particle and preposition case, can we do that better? No, probably not. Or for my dissertation work, looked at sequence in German, you can have these like, Mark Twain had this horrible German language, the thing where he says, And Germans, they have these words, and then at the end of the sentence they throw in a couple of verbs just for the fun of it, you know. Hätte, könnten, sein, wollte, was weiß ich. And you can actually find sentences like, er wird das Buch haben kopieren lassen müssen. He will have had to let copy the book.
Yeah, where you have all the verbs at the end.
Exactly. And then you ask yourself what's possible. And if you think about, let's look at large corpora, should be possible, but the one big problem of German is that it has non-finite verbs which look a lot like plural finite verbs, like they walk and they will walk. The walk, just like in English, always has the same form. So now put them in a verbal complex, 3-4 verbs together, and you're interested in where can finite verbs occur. And the part of speech checker will do a very poor job in finding out where is the finite verb, where is it not. So you need some more specialized technology. You should do some kind of either, you know, look at it by hand. If you find interesting cases, you can sort it out first, get good recall, low precision, and then figure it out yourself. Or you have some machine learning setup where you hand annotate some data and then try to learn about the characteristics. So you need both. You need the theoretical ideas about what's interesting, the data giving you instances, representative instances of the domain that your research question is about. And then you need to enhance this data. Now you have billions of words sometimes, web corpora or subtitle corpora that Mark Brisbert is now doing. Very interesting because they correspond very closely to the human experience. You can do lexical decision tasks and see how quickly do people react to, yes, it's in the language, no, it's not. And the frequency of occurrence of words in subtitle corpora very closely, it's a very good characterization of the reaction time that people will have to those words in lexical decision tasks. So we have these large corpora, but the question is, how do you now find the sub-instances, the subsets, that actually relate to research question like, I wonder what Germans really do with their verbal complexes. And then you need to annotate. And then you need to basically, that's exactly what I'm going to talk about this afternoon, that you then need to provide a way to access data that is relevant to what you're interested in. In this, it's like the needle in the haystack. And how do you do that? And then there's a big danger that if you just say, well, learn a language, let's say language used by language learners, it's very similar, you know, depending on the level of proficiency with a native one, and you just label it with the same part of speech text and without any difference. And then you've got a sentence like, he was choiced for the job. Well, so what is choiced? Is that a verb? Well, has an ed ending, a bit of morphology in English. Hey, it tells us it's past tense, it must be a verb. But then you look up the lemma. Is choice, what is it? Is it, well, choice is adjective or noun, a choice beefsteak or I have no choice. And then he was for a job. That's the distributionally that looks like a verb slot. And then you ask yourself, okay, depending on how you label it, you actually always make a mistake, and depending on your research question, you won't find this example if you label it in the other way. Or I met my wife during I was in prison. You understand what it means. But
so a human being can sort of figure out the meaning even if this doesn't follow the sort of standard grammar of the language, but can a computer figure out how to tag?
Yeah, but also kind of then can a computer figure out, but also what did you want for your research question? Were you interested in something? Imagine you're now actually interested in ways to connect sentences. You're studying how do language learners learn how to connect, you know, temporal, causal, you know, because and when and all these kind of connectors. And then you ask yourself this during. Would you count it? Well, probably you'd be interested in it, but if you label it as a preposition, during is a fine preposition, you know, during school and so on. But here you still understand it, but it's wrong. So if you label it as a preposition for your research question, that example will not be retrieved. So you will not find that learners do exactly what you just said. They seem to apparently, in expressing their ideas in the second language, they seem to be following meaning with limited ability sometimes to access morphology, limited ability to access distributional patterns, and then they mistake parts of speech classes, but they follow, you organize in your mind, in your brain, you organize words differently. You can access them by speech, you can, so first phonological segment, by meaning, and you sometimes then retrieve antonyms. You want to retrieve hot, but you actually retrieve cold. So we know a lot about, or people know, I know very little things, but in principle, the idea is you try to connect what humans do and to understand how humans acquire language by looking at corpora, but then you need to access your corpora in a way that allows you to characterize things like during, or in a sentence like I met my wife during I was in prison, or I was choiced for the job, but then you can't use the standard tag set. So our proposal then to do is, let's use 3 tag sets. Let's record distributional evidence, let's record morphological evidence, let's record lemma evidence, and then every researcher themselves, multi-layer, fortunately technology is now there that you can just annotate lots of layers of information that annotates, that interprets data, so that you then can actually access for your research question the right subsets of data. So in a sense now you can see we've got our theoretical considerations, we've got the data, and now the annotation needs to make sure that the annotation reflects the characteristics of the data, which again for theoretical reasons we're interested in. For example, how do humans access lexical material in their second language? What are their strengths, their deficiencies? How can you support their learning and foreign language teaching and learning? Those kind of ideas.
You mentioned learner corpora and the application of computational linguistics in applied research and applied linguistic research. Would you tell us a bit more about this, and sort of computer-assisted language learning is another area that sort of is related to this. Where do you see the role of learner corpora in research?
Yeah, that's a very interesting question. That's one thing I've gotten into a lot in last perhaps 10 years about now. Because learner corpora allow you to ask new research questions. At the same time, they've been around for a long time. Every language teacher out there has a record of interesting examples they've collected from what people wrote. And
so they can build their own learner corpora very easily, and we in MOOC actually give people tools to do it themselves. And this doesn't have to be a large learner corpus; it can be a very small one.
Yeah, and that's interesting. And so you start out with, and people have always for years, not just since the 90s, where the first larger learner corpora came about. And the difference then was what people collect themselves. At first, is just a kind of, you find something interesting, it's not representative of learner language as a whole. And it can inform your kind of, where are my students, for example, at? You give them an essay, they give back the essay, you find out, oh, they have problems with this and this, and then you bring up the topic in one of the upcoming sessions, if you have the freedom and aren't required to have a fixed curriculum. And but then if you want to go beyond this kind of monitoring what this particular group of students has done, monitoring particularly interesting examples that you find interesting, because interesting isn't a good scientific criterion. Then in the 90s, people like Sylvian Granger basically said, let's do a systematic collection of learner data. And then the question is, systematic for what? And they decided at the time that if you give them a particular topic like women today have an easier time than, I'm actually putting 2 things together. There's 2 topics. One is the older generation had a more difficult time than the younger generation, and then kind of you write an argumentative essay.
Something everyone can relate to.
Everyone can relate to, because and the other one was with women, that emancipation of women has hindered women more than helped. So something where you have an opinion you can relate to, and you're going to write about related contents, so that it's now comparable. Say you are in the Czech Republic, I'm in Germany, and someone else maybe in Bulgaria, the United States, England, and we all write about the same topic. So the main difference, we would hope, partly our opinions may differ of course, but still one big difference will be in the way that we have acquired and the way we're learning the second language, if we all write in English, for example. And then the question is, how does your first language influence the second language, so-called L1 transfer effects? And so there's a different kind of topics you can now ask of these new representative corpora, which are bigger, like the ICL, the International Corpus of Learner English. But still, if you think about it, how representative of learner language is it to have written essays? Then you can find out that you can ask certain research questions, but others not. For example, Miura, researcher in Japan, he had a translation corpus in which he had the question, there were certain words to be translated, sentences to be translated, and then there was the learner responses. I know his lives, I don't know where he lives, I know he lives, or something, a collection of with negation, without negation, with lives and with lives. And you wonder what were they trying to do, and only because, if I now tell you that actually the proper English translation of Japanese was, I don't know where he lives, and they were supposed to translate that. Only then can you get a handle on what were they trying to do. Did they have problems with do support? Did they have problems with negation? So suddenly you realize we need to know more about the task.
The effect of the task, actually.
The task, so input and prompt in learner corpora, exactly. And then you can see things are developing now, and they're developing an area which for a computational linguist is interesting, because in computational linguistics what you also do as some small subgroup of people are interested in tutoring systems. So tutoring systems, the idea is you work on some exercise and the machine provides you with immediate feedback. It can be different feedback. Usually it's feedback on form, like grammatical mistakes you've made, orthographic mistakes you've made, but could also be feedback in terms of meaning. So on the Tagarela system that Luis Amaral did with me, this PhD project, we combined feedback on meaning and feedback on form in, for example, reading comprehension or listening comprehension tasks. And this was for Portuguese, but it could be done for different languages. And the Tagarela system was used in real-life classrooms. And suddenly, in real-life classroom, you get real-life learner data. Because these learners type in their answers, and the system partly analyzes it, provides feedback, scaffolding feedback ideally, where you incrementally lead the learner to kind of master, to correctly produce the language, correctly in meaning-based task. So both correct in terms of meaning as well as the forms that you're using. And you can step-by-step help them, and then you can even monitor in your corpus this incremental nature of what did the learners understand, was their uptake, how did they integrate what the feedback you gave, what it meant for their own productions, and which can go wrong. For example, there's this great Monty Python sketch about the dirty Hungarian phrasebook joke. And the guy comes in and says, I will not buy this record, it is scratched. And the guy says, so now comes the feedback. Sorry, sir, this is a tobacconist. He says, I will not buy this tobacconist, it is scratched. And so you can show that, well, wait a minute, there was feedback, but did the guy
so no uptake, basically, in
so
linguistic terminology.
And you actually wonder then, where can you monitor this? When is feedback understood? When is feedback not leading to corrected productions? And suddenly these kind of corpora that could be, right now they aren't really much collected, but could be collected in intelligent tutoring systems, would have more of a task structure, would know more longitudinally about a particular kind of learner, and you would then be able to interpret incremental productions, if you include the feedback and see under which conditions input is interpreted in which way. And that opens up a whole, in a sense, world of, what if you have input enhancement, if you enhance the input in a way that you highlight certain categories so that the learner, that it's more salient to the learner by marking a preposition in blue. And that's what we do in a VIEW project, the visual input enhancement of the web project, where we try to support learners in interacting with with some information they're interested in. You're interested in, go to Reuters News, you type in, war in Ukraine, or hopefully not war in Ukraine, and then you basically get text you want to read, but at the same time I highlight the prepositions for you so that you become more aware of.
Is it a tool that is currently available?
That's a tool that's currently available.
We can sort of put a link to the website if people want to sort of try this out.
We can try it out. It's the VIEW system is right now a Firefox add-in, so that you can, any web page you have, you can highlight different language characteristics, such as prepositions, article choice, and you can either just highlight or can actually automatically turn it into activities, where you can turn any text they have into multiple choice activity or fill in the blank activity for any kind of any kind of web page you can access, and that's why it's in your browser, but it doesn't otherwise. So there's no NSA looking over your.
Brilliant. So there's a lot of technology that people actually can use in that particular context that can support learning, and that we can use actually for researching actually what's happening, the process of learning.
And you need to then keep the two things if we want to use it for research. We actually have a version of the tool that records more things. That's why I was mentioning the NSA there. That once you load things in your web page, you of course want to make sure it's not in your web browser. Then you of course want to make sure that actually your browser is your browser and not that people aren't snooping. And but there is a research version of the VIEW tool, and there's a particular variant called Wordy, working with English real text interactively. where we actually set up experiments, and then for experiments you also need informed consent of the users, where they then basically write down, yes, I'm aware I want to participate in an experiment, and then we, in these more controlled conditions, we then actually monitor which pages are they looking at. Together with Patrick Rüberscha, we're just starting that particular experiment. What pages are they looking at? How many, in this case, articles were on there? Which ones, definite, indefinite? And then you can see with which interaction did which learner achieve which kind of learning gains with a post-test and delayed post-test. And that can then be used for research, or, as we were getting into this from corpora, you could collect corpora of these learner productions in intelligent tutoring systems, but then of course it's very important that we then follow proper procedures to have informed consent of the people participating in experiments, which one should then clearly separate from tools, making tools available on the web, where basically you need to know what's being sent. And for example, for Vue, currently we record which web pages are enhanced, and we tell you if you go on the about, but we don't record interactions of how often did you click on which, these kind of things. And that is something to keep apart from experimental conditions where you need more.
So very, 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 very useful tool indeed. Detmar, my last question: Will computers be ever able to understand human language? I know that this is a very general and popular question, but what would be your response to that one?
It depends on what you then mean by understand. So, for example, one area where I was struck by, how do I phrase this in a diplomatic way? I was surprised by a statement by a German researcher who was asked about they do automatic text simplification. So they take, not automatic, they do manual text simplification. They take a text written by some German bureaucrat, the famed German bureaucrats writing incomprehensible language. And then the question is, how do you turn it into something that actually people can understand? Imagine, migrant population or just ordinary Germans. If you look at bureaucratic language, it's hard to understand. And they have this kind of simple language. And the statement in that news report ended with exactly a question like this: couldn't you do some of this automatically? And the person said, no, of course not. It's about meaning. And I thought, wait a minute. So meaning doesn't mean computers can't compute on representations that to us relate to meaning and life and function of language and life. Because the key thing is, I mentioned distributional semantics. What does the word, for example, chicken mean? Well, you type in chicken into some machine, and then it can find out in which context it occurs. Chicken often either occurs with farmyard or it occurs with Kentucky Fried. And so either food kind of context or kind of farm kind of context, and probably lots of other kind of context. But in principle, you can infer by the company this word keeps, first thing, the idea.
So collocations, basically.
Collocations, but also you can actually figure out a new word. What may this mean? And that means that you can then have projects, and one of the projects I have, that's why I was a bit surprised, is comparing the meaning of answers to reading comprehension questions. We automatically, if you give us a question, reading comprehension question, and answer, and the target answer that all of the teachers are supposed to use for grading, then you can figure out with 86% accuracy, about for English and German, whether this answer is correct in terms of meaning or not. And the way you do it is you look exactly at which words were used, which other words are similar. Where was Bob Hope when he heard the news that he's supposedly dead? He was at home. He was at his place. He was in, and then some address. All of these places relate to the same location, but they're different forms. So you need to go beyond forms to meanings. And you can also do that with automatic analysis of readability. So another project Soumya Vajala and I have some papers on, which are also on the webpage. If you go to my homepage, you can find.
So we can just again put a link to your homepage where people can read more about these fascinating.
Yeah,
things.
and then she. So what we do there is we automatically analyze the complexity of different kind of texts, and then find sentences that are particularly worthwhile simplifying. For example, by taking a relative clause out and making it a separate sentence, or by using a more frequent word that is a close synonym in this context of a particular word. So you can, in fact, manipulate, and you were asking about understanding, you can manipulate forms in a way that corresponds to keeping a related meaning or the same meaning, but simplifying the form to do automatic text simplification or comparison of answers to reading comprehension questions. So just because computers will never understand, they don't have human experience. So to understand, can a German even understand what it means if you go to China and someone says something? Well, there's cultural differences. There's lots of, what is understanding if you go to Heidegger? there is no understanding beyond your.
No one can
intersubjective
understand
domain.
Heidegger. Probably the way Heidegger understood the things he wrote.
But there is an intersubjective domain, kind of, where we our interpretations are close enough so that if I say, "Do you want a beer?" and your understanding of beer is different, but you're from Czech Republic, so we have a similar understanding. You have good beers in Czech Republic, but the idea is that there are certain things which overlap and other things which don't. So understanding is a very complex notion. There isn't, I have an idea, I formulate the idea, pop, it's in your ear, you interpret it. It's not, communication is not symbol passing from my mind to your mind.
So would it be fair to say that computers can handle language in a very sophisticated way, and this is our goal in computational linguistics and in computation as a sort of general field?
It's not the only goal. There's the field has really gone into many directions, but in terms of understanding, I think it is possible to, using computational linguistic tools trained partly on large corpora, corpora of, for example, reading comprehension questions and answers, to actually perform tasks that for humans require understanding, namely to compare meanings to answers of reading comprehension questions, is to compare meaning of answers to reading comprehension questions. That for humans clearly requires understanding. You don't do it by marking up, words separately. You ask yourself, what does it mean? Did they get the contents of the text? And that is something you can do with computational techniques, but you will, of course, not try to model human understanding and human textual representations. What do you have in your brain? You try to be informed by it, but you don't try to model it itself.
Wonderful. So, well, that's an optimistic note, and we can probably finish with this one. Detmar, thanks very much again for talking to me and talking to our MOOC participants. Thanks very much.
Yeah, thank you very much for having me here.